So here is the problem. We're given a list, the integers between 1 and 10, and from this list we need to find all numbers x such that part A, x is less than 7 and x is less than 4, and part B, x is less than 7 or x is less than 4. So notice that part A and B are nearly identical. The only difference is the words and or. And that is what this problem is about. The first approach would be to grab individual numbers, 1, then 2, then 3, and so on until we reach 10. After all, 10 is not such a large number, and test every single number against the compound statement, whether the statement is true or false if we put that number into x. For example, let's say x equals 1. Is 1 less than 7 and less than 4? Well, these two statements are true, so the compound statement is true. So 1 is going to be on our list for part A. Okay. Now, while we're at 1, let's see what about the or statement. 1 is true or true. That's even easier, right? So that's true too, and so 1 is on both lists. What about 2? 2 is less than 7 and less than 4, so that means we're talking about A and B, where both A and B are true, and A or B, where both A or B are true, and so 2 is on the list too. We're going to find the same thing with 3, but 4 is where life gets a little bit more interesting, because when we reach 4, the second statement here stops working, and from now on it's not going to work, right? The numbers from now on, 5, 6, 7, 8, 9, 10, none of them is less than 4. So now what we have, if x is 4, 4 is less than 7, 4 is less than 4, we're talking true and false. So if the word between them is and, for this statement to be true, both parts would have to be true. So this compound statement is false for 4. In other words, 4 is less than 7 and 4 is less than 4 is a false compound statement. So 4 is not on this list, but it is on the second one, because 4 is less than 7 or less than 4, because it is less than 7, right? So 1 true, 1 false, that might be not good enough for the and, but it's good enough for the or. Okay, what about 5? We'll find 5 is less than 7, 5 is less than 4. The second statement will not be true from now on, right? Which means we're not going to find anything here. We're done here. 1, 2, 3 is the complete list. No one else on this list would work with the second statement. Now what about 5? 5 is still less than 7, so for the or statement 5 works. And we could say in mathematics, yeah, 5 is less than 7 or less than 4. Same with 6. And then 7 is where they both stop working, right? 7 less than 7 or 7 less than 7 is false, and 7 less than 4, if possible, even more false. So that will be false for both and or, and same with 8, same with 9, same with 10. So the two solutions are the integers from 1 through 10 that are less than 7 and less than 4 are 1, 2, and 3. And the ones that are less than 7 or less than 4 are 1, 2, 3, 4, 5, and 6. And there's all kinds of other things that you might notice, but we're not going to kill the punchlines now. Think about it, and maybe we'll talk about it next time. Thank you for watching.